gateway. Payment gateway is the secondary one. Here what? Check type, expiry date is the another one. So what about DB tables, sir? DB tables. INH underscore. I think we have to take like this. Payment underscore TPSC. Parent DB table. Parent DB table. Here we are having PID PK. Next amount. Payment underscore card payment underscore TPSC. Card payment underscore TPSP. Card number. What is that? Card number. Card type. Card type. Payment gateway. Okay. Payment underscore mode. Payment underscore mode is payment underscore mode is foreign key column. I think I should not take payment underscore mode. It's a foreign key column now. Here also I have to take payment ID. Yeah, which will maintain foreign key column, which is a foreign key column holding PID. Next. Check payment underscore. Check payment underscore TPSC. Check number. Check type. Check type. Next, expiry date. Expiry date. Payment underscore ID. FK. Expiry date. Suppose if I insert record by using card payment class here. Pay ID, some number 123, amount some MR, this one, card number 4567, card type debit, payment gateway Visa, payment ID 123. This and this should match, guys. As you know that this and this should match. This and should match. We have another record, guys. 124. Here is what? All 6. Check number. Check type self. Expiry date. What is expiry date? So within 1 year, right? 20 October 21. Payment ID is equal to 124. Payment ID is equal to 124. Okay, nice. So now these two will be in relationship now. These two will be in relationship. Yes, guys. So this is about the whole process, guys. So here is my 123 red color. Here is my 124 another red color. Nice, nice. Right. Common columns. By default, discriminator column is optional. Here, discriminator column is optional or mandatory. Here, discriminator column is optional or mandatory. Optional, but if you are interested, you can take it. If you are interested, you can take it. Okay, now tell me how to develop these classes, sir. How to specify these primary key columns, sir. Let us develop the entity classes first. Entity classes. Yeah, first what here? Public class payment implements serializable. Implement serializable. Implement serializable. At the rate entity. At the rate table. Name is equal to. At the rate name is equal to. Tell me. Payment underscore table per subclass. At the rate inheritance. Strategy is equal to inheritance type dot. Here joined. What is this? Joined. Inheritance type dot joined we have to use. Fine. At the rate data, guys, to get the getter setter methods dynamically. Fine. Yeah, here is my private integer PID. Yeah, you can take wrapper types are good. Float amount. Float amount. Anyhow, getter setter methods will come dynamically, guys. Okay. So this is payment.java superclass. Payment.java, which is a superclass. Okay. Next. Oh, at the rate ID is required here. At the rate ID. Okay, I will adjust them also. Don't worry. Yes. Yeah. At the rate ID. At the rate generated value. Here is my abstract class. Definitely here is my abstract class. Next. Card payment dot Java subclass 1. Subclass 1. Card payment extends payment. Card payment extends payment. To tell that it is a entity. Here you have to mention table name. Separately you have to mention table. Card payment underscore TPSC. Card payment underscore TPSC. But here most important thing is primary key join column. Array, while writing joined hyphen subclass, generally we will write key column is equal to Primary key join column. It's alternate to key tag, boss. Alternate to key tag. Name is equal to payment underscore ID. Referenced column name. What is next? Referenced column name is equal to referenced column name is equal to PID. Private string card type. Private long. Private string payment gateway. Payment gateway. Getter setter methods will come automatic. No need of writing ID, guys. There is no need of writing ID. Yes, guys. Check payment.java. What is this? Check payment.java. This is my subclass 2. Check payment.java. This is my subclass 2. Say paste. Table is what? Check payment underscore TPSC. Primary key join column, same thing. Okay, here what is this? Check payment. Check payment. What is this? Check number. Check type. Check type. Next. Local date. Local date. Expiry date. Local date, expiry date. At the rate data will give me getter setter methods. Here also at the rate data will give me getter setter methods. I hope you got a clarity now. Here discriminator column is optional or mandatory. Here discriminator column is optional, but recommended to take. If you are interested, you can take. Yes, boss. Local data, local date. Fine, guys. Let us convert our yesterday's examples into this. Copy paste 61 NO TPSC table per subclass. TPSC table per subclass. Yeah. It does not take much time, guys. Only small changes in the table names. That's it. Table TPSC. Inheritance strategy is equal to joined. Discriminator column is not required. Next, card payment discriminator value is not required here. At the rate table name is equal to card payment underscore TPSC. Yes, here this is compulsory. Primary key join column. Primary key join column. Name. Okay, what is that? Payment underscore ID. This is foreign key column. You should refer what column? Referenced column name. PID. Referenced column name is PID. That's fine. Card payment. Check payment. Check payment underscore TPSC. Payment underscore ID PID. Remaining all stuff is same. Come on. Primary key join column name. Referenced column name is PID. Come on, guys. Same. Foreign key column name here. Foreign key column name here. So PID here. Remaining all stuff is same, boss. If tables are not there, it will create a new table. Annotation mapping test. So now it will create a new tables, guys. Run as a Java application. Run as a Java application. Objects are saved. Go to the top. Say refresh. Go to the top. Say refresh. Here, what is this? Payment underscore. Payment underscore TPSC data. Two common records have come. Two common records have come. Next, card payment underscore TPSC. Payment ID 29 has come. Come on, guys. Check payment underscore TPSC. Another this one also. Okay. Come on, guys. Easier, not easier. Check payment underscore TPSC. Things are happening as expected or not there. Okay. No, sir. I want to get same thing with the discriminator column. I want to get same thing with the discriminator column. I too never experimented, it seems. Okay, let's see. Discriminator. Minator. Discriminator column. I'll go to that project later. First of all, I'll come to the client application, select test, whether I'm able to get the records what I want or not. From payment should give me 2 records. From payment is giving me 2 records, including common data, payment common data. From card payment is giving me one record. From check payment giving me one record. From check payment giving me one record. Everyone understood my point, guys? Come on, guys, come on. Easier, not easier. Now I want to see the same application with the discriminator column. Go to entity class, payment.java. @discriminator column. @discriminator column. Name of the column. Payment underscore mode. Payment underscore mode. Type string. Type string. Length some 10. Length 10. Payment underscore TPSC1. Close all editors. Card payment, guys. Card payment underscore TPSC1. Card payment underscore TPSC1. Yes, okay. Now here, discriminator value. Discriminator value, what is that? Card. Yes. Discriminator value card. Check payment, guys. TPSC1. Discriminator value. Come on. Discriminator value check. Fine. If table is not there, it has to create the new table. Fine. Right click, run on Java application. Right click, run on Java application. Objects are saved, guys. You say refresh. Payment underscore TPSC1. See, boss, discriminator column came, not came. Guys, are you with me? Discriminator column came, not came. And that came means I need not to do anything great. So here discriminator column is optional but recommended to take. So that's why what should I do? I will go to one extra column. What is that? Payment underscore mode. Okay, discriminator column. Discriminator column. Yes, what is the value I have taken? I think 123 is belongs to card payment card. This will belong to check payment, check will come. Check payment, check will come. That's not so important, but we should also write same information here. How to write that same information here is oh, space problem now. How to adjust that, guys? @discriminator. @discriminator column. Name is equal to payment underscore mode. Payment underscore mode. Disk length is equal to 10. Length is equal to 10. Yeah, discriminator type also you should specify. You know that, but I am not highlighting this because default is string only. That's why. Here is my @discriminator value. Check. @discriminator value check. Here is what? Or here check. Fine. Here check. Here it should be card. Here it should be card. Fine, boss. Are you understanding my statement, guys? Come on. Easy or not easy? Discriminator column is optional but recommended to take. When it is recommended to take, you have to configure discriminator column and value. Easy na, guys? Right. What is the next one? I would like to go for table per concrete class. Annotation driven table per concrete class. Are you listening? Annotation driven. Because in annotation driven environment, inheritance mapping is possible only in 3 ways, guys. Only in 3 ways. Annotation driven inheritance mapping. What is this? Table per concrete class. Table per concrete class. Annotation driven inheritance mapping table per concrete class. Yeah, same old 3 classes, guys. Same old 3 classes. When it comes to DB tables, am I going to do any record insertion using superclass? No. So when I'm not going to do any record insertion in the superclass, I think now no need of taking separate table for superclass. Why, sir? Array, anyhow, subclass tables also will have common columns and specific columns. Now, is there any need of configuring table for superclass? No. No. Sir, in table per subclass we have done, na? Array, there that is acting as a parent table to have a relation with the child table records, that is done. But here no relation between tables. Moreover, subclass tables will have common property columns and specific property columns. So that's why straight away card payment underscore table per concrete class. PID, PK, PName, not PName, sorry, amount, card number, card type, payment gateway. Next one. Check payment TPCC. Check payment TPCC. PID PK amount, check number, check type, expiry date. Expiry date. Yes. Is there any need of separate table for superclass here? Is there any need of separate table for superclass? So that's why let me write that comment. Since we are taking superclass as abstract class and we are not going to do any persistence operations, using superclass, any persistence operations using what? Superclass. And we are not going to do any persistence operations using what? Superclass. Understanding my statement there or not there? Any persistence operations using superclass. So no DB table is required for superclass. So no DB table is required for superclass. Is there any need of DB table for superclass or there is no need of DB table? In this model, not required. Suppose if I do card payment, 123, all files, card number, card type debit, okay, payment gateway, Visa. See here, common columns are there. 124 amount, check number, check type, self check, expiry date 21 October 2022. Guys, I hope you understood this story. Why I have not taken any class? Why I have not taken any class for any table for superclass? Yeah, because it is an abstract class. So using that no persistence operation. It's a concrete class. It is a concrete class. I hope you understood my point there or not there. Yes, guys. Annotation driven inheritance mapping, table per concrete class. Yeah, how to design these classes, guys? Payment.java. Public class payment. Implements. Serializable. Public class payment implement serializable. Tell me. At the rate entity. At the rate data. At the rate inheritance. Strategy is equal to. Strategy is equal to. Tell me what is the value? Inheritance type dot table underscore per underscore class. At the rate table. Here table required. For superclass table required or not required. That too we decided to take this class as what? Abstract class. We decided to take this class as what? Abstract class. Private integer. Private integer PID. Yeah, tell me. At the rate ID. At the rate generated value. Yes. At the rate generated value. Private float amount. Yes, guys. So this is what your super class. This is seriously nothing but super class. Card payment.java subclass 1. Public class card payment extends payment. Public class card payment extends what payment? Extends what payment? Tell me here what is this? At the rate entity. What is that guide here? At the rate entity. Are you there with me, guys? Come on. At the rate entity. Next. At the rate table. Name is equal to card payment underscore TPCC. Card payment underscore TPCC. At the rate data. Yeah. Private long card number. Private string card type. Private string. Come on. Private string payment gateway. Only strategy, guys, remaining all are same. No need of specifying primary key join column anywhere because no need, no foreign keys. When foreign keys are involved, then only primary key join column. What is this? Check payment. Subclass 2. check payment underscore TPCC, check payment underscore TPCC. Come on here. At the rate data, public class. What is this? Check payment. Extends payment. Remaining all are normal. Yeah. Here what? Check number. Check number. Next. Check type. Check number. Next what we got? Check type. Next local date. Local date. Expiry date. Local date, expiry date. Local date, expiry date. Yes, guys. Easier, not easier. Come on. Right. Yeah. Is there any need of discriminator column here? Since every class is having separate DB table. So every class is having separate DD table. Is there any need of discriminator column? Since not. Since every subclass is having separate DB table. But yeah, separate DB table. So there is no need of taking. So there is no need of taking discriminator column here. So there is no need, there is no necessity of taking what? Discriminator column here. Is there any need of taking discriminator column, guys? Is there any necessity of taking discriminator column, guys? Come on. Yes, guys. So there is no need of taking any discriminate. Tell me, this strategy is good strategy or bad strategy? Bad strategy. Why? Duplicate columns are coming across the multiple tables of multiple subclasses of inheritance hierarchy. Common columns are repeating. That's why it's a bad designing. What is the good approach here? What's the good approach? Okay, table per subclass. Sir, for superclass, do I write at the rate entity? Don't write, not a problem. Do I need to write at the rate entity? Not, if you don't write, also not a problem. Because I am not going to do any persistence operations using this. But this inheritance strategy is compulsory. This inheritance mapping strategy is compulsory. Shall we convert this one quickly? (62) with the discriminator column 62. (63) inheritance mapping table for concrete class. Here no question of having. Payment.java TPCC. No need of this. What is the value, guys? table underscore per underscore class. Yes. Table underscore per underscore class. If I don't write at the rate entity, at the rate ID, at the rate generated value will work or not, will not work. You should write at the rate ID, at the rate generated value compulsory, because these common columns also present in the subclass related tables, boss. So you must take at the rate ID, at the rate generated value compulsory. I hope you are understanding. Fine, but no need of taking table. I too agree that. Okay. Yeah. So at the rate ID, at the rate generated value common, because in the subclass related tables also these two are, this is the identity column. Fine. Just sit and experiment so you will get to know. Entity data, TPCP, not required, remaining things are same. Here inheritance mapping strategy is mentioned, guys. Okay. Card payment, entity data, this is required. TPCC, this is not required, this is not required. Understood my point? Here is my payment, here is my check payment, here is my card payment. Let's observe. Run on Java application. Now you observe. Insert operation credit card payment, insert operation in check payment. Those two tables are again created dynamically. Card payment underscore TPSC. Yes, it's showing. Check payment underscore TPSC. Yes, it is showing. Come on, guys. Did you notice it? Yes, guys. So now let's see the retrieving part. Run as Java application. When I say, see, it is using union. It is using lot of union. Okay. Two records are coming. It's saying what? Two records are coming. That means by default it is showing implicit polymorphism. Only one record. Here only one record. Here only one record. Here only one record. By default it is showing implicit polymorphism or table per concrete class. See, union tag has come. That means it is showing table per concrete class. It is not showing any implicit polymorphism. You observe the difference between both here. Okay, you observe the both. I opened this TPCP test, inheritance mapping select test. Click on it. Click on it. Yes, here, okay, we got all records here. Let's leave it. We got all records. But what is the tag? What is the query using? Union. The query is using union word, right? Okay. That is table per concrete class. Okay. Now, next what I have done. Table per concrete class with implicit polymorphism. Test. Having same data, I run the application. Having same data, I have run the application. This time what happened, guys? What happened, guys? Oh, this is insertion, sorry. I want to execute select query. That is in active mode. Look at the query, boss. Look at the query. No union, nothing. No union, nothing. Sir, only parent records are coming. Yeah, parent records might be coming because I have enabled explicit polymorphism there. Mapping file, guys. Here I have written, okay, let me write implicit polymorphism. What are implicit polymorphism? Java application. Yeah. Yeah, not the output, guys. Common records are coming. It is generating 3 separate select queries. 3 separate. That means inheritance is not highlighted. Inheritance is not highlighted. Okay, when inheritance is highlighted, then it is going for union. Come on. When inheritance is not highlighted, it is going for 3 individual select queries. Now tell me, guys, I'm saying from person only, but we are getting 3 individual select queries. For employee separate select queries, for customer separate select query. So that is table per concrete class with implicit polymorphism. When you go for table per concrete class, okay, it will generate query by using union concept. What concept? Union concept to get okay, to get records from parent using parent table, subclass 1, subclass 2 tables. But when I go for what is that implicit polymorphism, classes inheritance is not highlighted in the mapping file or annotation. That's why it won't use union. It will generate what? Multiple select query when I say from parent class. Generates multiple select query. When I say from parent, it will not generate only one query. It will generate multiple queries. One per pair, one based on parent, one based on child 1 class, one based on child 2 class. Did you notice it? Now, what point I want to highlight is when I go for inheritance mapping concept here, guys. When I go for inheritance mapping concept here is table per concrete class. Here is my test. Select test. Run as a Java application. Run as a Java application. So tell me here, you are still getting union. Union means what? It is by default, it is implementing table per concrete class. No implicit polymorphism is implemented. No implicit polymorphism is implemented. Did you notice it? Array, no implicit polymorphism is implemented. Not even explicit polymorphism. Explicit polymorphism means you should not get any records when I say from parent. But still I am getting records of child table 1, child table 2. Subclass table 1, subclass table 2. Here just table per concrete class. Table per concrete class is implemented. No implicit polymorphism, no explicit polymorphism. Everyone got the clarity? So that's why in annotation driven inheritance mapping, there is no provision to work with table per concrete class with implicit polymorphism. Table per concrete class with implicit polymorphism. Did you notice it? In annotation driven inheritance mapping, there is no possibility to implement. There is no possibility to implement. Come on. In annotation driven inheritance mapping, there is no possibility to implement. Tell me here. Implicit polymorphism. Implicit polymorphism or explicit polymorphism. Explicit polymorphism. Explicit polymorphism based table per concrete class. Concrete class. Inheritance mapping strategy. Inheritance mapping strategy. What's the difference between table per concrete class and table per concrete class with implicit polymorphism? Answer. In table per concrete class, in table per concrete class, the HQL query that is developed based on superclass generates SQL query with unions with union option, generates what here? Generate SQL query with the union option. What option? Union option to get generates single SQL query with union option to get parent DB table, comma, sub DB tables. Superclass DB table, comma, subclasses DB table columns. Subclasses DB table columns. In table per concrete class, the HQL query that is developed based on superclass name generates single SQL query with the union option to get superclass DB table and subclasses DB table columns. Understanding my statement there or not there? Yes. In table per concrete class with implicit polymorphism. Implicit polymorphism. The HQL query that is developed based on superclass name generates multiple SQL queries with implicit generates multiple SQL queries to get records from superclass DB table columns and subclass superclass DB table column subclass superclass DB table rows and subclass DB table rows. I hope you understood this point, guys. Come on, come on. Here union option is used to get all the records. Here no union option, only multiple queries will come. Check it out. Here what is coming? Union option is coming. Select star. Select star. From a union, select PID. Yes. Here is PID amount. Here PID amount, check number, check type, expiry date, from check payment, union. Come on. Okay, I think after first one also union is there, it seems. First one, union. Okay, only one time union is there. Here also one time union. First one, yes. First one, it is selecting all the columns that are there. I just said star. Like this query will come here, union based. So when it comes to this place, what happens? Select star from payment underscore TPCC. Select star from card payment underscore TPCP. Check payment underscore TPCP. It is hitting the database how many times here? 3 times. But here all together is coming in a single query using union concept or not? Using union concept or not? Come on, guys. I think already I have given difference between implicit polymorphism and explicit polymorphism. When I say implicit polymorphism, what happens, guys? You will get common records and specific record. When I write the query by using parent class. What is explicit polymorphism? You will get only one record using which what is inserted to parent class. What is inserted to parent class, only that record will come. I hope you understood that point. Implicit polymorphism and what? Explicit polymorphism. Can I bring the effect of implicit polymorphism and explicit polymorphism in the annotation driven setup, boss? Can I bring the effect of implicit polymorphism and explicit polymorphism in annotation driven setup? No. Why? Table per concrete class is supporting only table per concrete class. It is not supporting with implicit polymorphism or explicit polymorphism. That's why there is no provision to work with implicit polymorphism and what? Explicit polymorphism. Okay, boss. Note. In annotation driven inheritance mapping, there is no provision to work with both implicit and explicit polymer. We cannot. There is no provision to work with both implicit and explicit polymorphism. I hope you got a clarity there or not. Easier, not easier? Come on. So that's why in XML driven inheritance mapping, total how many strategies are there, guys? Four strategies are there. How many strategies are there, guys? Four strategies are there. How many are there? Four are there. But here how many strategies are there, guys? Only three are there. Did you notice it? Only three are there. Only three are there. What are those? Can you name them? Table per class hierarchy, table per subclass, table per concrete class. Table per what? Concrete class. I hope you understood my point there or not there. Yes, guys. So TPCCH, TPSC, TPCC. What is industry standard? TPSC, table per subclass, because table designing is perfect in that situation. No duplicates, nothing. That's why it is what? Table per concrete class. What class? Sorry, table per subclass is the inheritance mapping style. That's a default one. Okay. See, there is an option to specify polymorphism. Let me verify this. Used to define polymorphism hibernate apply to the entities. So here there is a @ polymorphism tag is there. Type is equal to polymorphism type dot explicit I have written. Polymorphism type dot explicit I have written. Wait. An annotation inheritance mapping select test. I have written explicit. I have written explicit. Still we are getting two records. Did you notice it? Still we are getting two records. Are you observing? Still it is using union. Still it is using union. Are you comfortable with me or not? We are not getting the feeling of implicit or explicit. So now I will change to implement. Then I will change to implicit. Now I'll change to implicit. Select test. Still it is using union. Did you notice it? Still it is using union. Observing. No, sir, I want to get the effect of implicit polymorphism or explicit polymorphism in the annotation driven environment. Okay. By default. Using default setup. Using default setup. Understanding my point? Using default inheritance mapping setup, can I bring that effect? Can I bring that effect? No. But I want to enjoy implicit polymorphism and explicit polymorphism. Only one thing we have to do, guys. Only one thing we have to do. Let me try this. In the payment, no, don't mention any strategy. Don't mention any strategy anywhere. Come on. Don't mention any strategy anywhere. And I have mentioned polymorphism as implicit. I have mentioned polymorphism as what? Implicit. Now you observe. Now you observe. Now you observe. Yes, we are create table payment. No. It is going for table per concrete class. Check it out. It is going for table per concrete class. It is creating multiple columns. Listen carefully. It is creating multiple columns in a single table. Yeah, because that is the default strategy. That is the default strategy. Are you understanding, my guys? That is the default strategy that it is following. Okay. So overall conclusion is what here? In annotation driven inheritance mapping, there is no provision to implement implicit polymorphism or explicit polymorphism, even though you are dealing with what? Even though you are dealing with what? Okay, at the rate polymorphism tag. So there is no provision to deal with that. Everyone understood my point? Yeah, for other angles, they have given at the rate polymorphism, but in this angle, it is not possible. Right now, there is no work with polymorphism annotation, boss. I think you observed that one carefully, guys. So that's why this statement is important. In annotation-driven inheritance mapping, there is no provision to work with implicit and explicit polymorphism using default setup. I hope you got it. Fine. Sir, that is Hibernata, JPA, that does not matter, guys. Fine. So this is about annotation-driven inheritance mapping. So once again, let me give clarity. In an XML, how many inheritance mapping strategies are there? 4 are there. What is extra one? Table per concrete class with the implicit polymorphism, right? In annotation driven inheritance mapping, how many mappings are there? 3 are there, which is not possible to implement. Table per concrete class with implicit polymorphism, not possible. It does not mean explicit is possible. Both implicit, explicit, not possible. Only table per concrete class implementation is possible. Table per concrete class implementation is possible. Everyone got the clarity there or not there? Enjoyed this point? Okay. So with this, we completed what? Inheritance mapping. Tomorrow onwards, I'm going to discuss about, I'm seriously, literally going to talk about, what is this? Collection mapping. What mapping here? First collection mapping, then association mapping. I hope you got, I have done this one. What is that? First collection mapping, then association mapping. Yeah, this weekend no workshops are there because I'm busy with evening 6 o'clock spring batch. Once that batch is over, we will think about workshops. Thank you, guys.